Good evening. This is our final project presentation on our speed detection system using OpenCV, presented by Kasasa Livingston Trevor, me, and my co-workmate Kalima Mati. So we have used an open dataset. Since our dataset was a video, like this is the content of what we are going to present. We have the introduction, the background and motivation, literature review, methodologies, dataset, and our Python source code, a conclusion and future works and acknowledgement plus our references. So I'll start with the introduction. We know that road safety is a significant concern with a high number of road accidents reported each year. According to just released police annual report of the 2021, there has been a 42% increase in the number of road accidents in Uganda. Overspeeding has been among the three main causes of road accidents. We therefore came up with a speed detection system that utilizes computer vision techniques to detect video speed in almost precise manner. Like if you have to take note of what is currently happening in our, many people are dying because of these road accidents. We have got many losses because of road accidents. And this basically comes in through overspeeding. So we decided to come up with a system. This system can detect a car that overspeeds, a car that violates traffic rules. So what motivated us, and what's the background behind our project? We have the OpenCV that we have used, open source computer vision library that provides tools of image processing. So basically, since that we are dealing with image processing, we decided to pick up an OpenCV that has all this information that we need. We are using speed detection, the process of measuring the speed moving objects. Since we have moving objects, we shall have to measure the speed at certain points. So computer vision, field of artificial intelligence that enables a machine to understand visual data. Then the optical flow, computer vision techniques that estimate the motion of objects in a video sequence. And background subtraction, video processing, and video sequence as shown below. Now, these are some of the things that relate to our project: real-time vehicle detection, tracking and speed estimation based on Gaussian mixture models. And we also have a vehicle speed estimation based on the machine learning using camera images, real-time vehicle detection, tracking, speed estimating cloud environments. Then our research gaps, basically, as we do this project, we know that we have many hinders that might hinder our project from being 100% accuracy. Accuracy. Since we are using learning models like the supervised and unsupervised techniques, these that may not detect all the instances of speed. These we might have errors of, let's say, moving people along the way. So all these objects, let's say like moving objects, wind, what, this reduces the accuracy of our project, the scalability. The model may not be able to handle large volumes of data. Let's say like our model based that it's going to be a real-time system. It does not have a working database. So what does it imply? It implies that we are not going to have the more the volumes of data increase, it also reduces on the accuracy of our model. Then, in brief, if I'm to summarize what we did, we integrated the convolutional neural network. This one is used for classification of vehicles with computer vision techniques to form a holistic permission solution towards speed detection and traffic monitoring. Now, I will give you a brief of my methodology. Basically, I'm going to collect data, clean it, split it so that I can easily work with it. Then I'm going to train this data. I will test it. Then I'll integrate the background. I'll integrate with background extraction and speed detection algorithm. The evaluation framework was used to increase cross-validation and error analysis. Cross-validation was used to access the generalization performance of the model. Error analysis was used to identify the types of errors made by the model. Then we come to our dataset description, where this is a combination of image frames containing pixels which carry two types of data, the background and the static objects, and foreground with moving objects. The factors considered in the selection were data relevance, data equality, data size, and cost. You know that as we pick our data, we looked at all these factors to see that we are able to come up with the best. The important features used by the model are vehicles, vehicle position, frame rate, road making, and timestamps used to calculate the time elapsed. Data preparation and exploratory data analysis. Here we used box plots. Outlier plots and correlation matrices are used to visualize and analyze data in a tabular format, hence not applicable for our project. We managed to generate a heat map that shows areas of high concentration of the traffic, and we also carried out a background extraction using our OpenCV so as to obtain a foreground that necessarily flow speed calculations, as shown in the next slide. This is my heat map, whereby where you see red when it is, where you see like dark red means that those are areas of what? Higher concentration. Now, as the red comes to reduce, we come to orange, something like that. Those are areas of, it's next to high. Then areas where you will see like a lighter color. Then those are areas with few concentration of cars. Basically here we are looking at vehicles. Now where you see blue and what there, that there they do not pass, they are completely light blue and blue. This is a sample of my background extraction. I started with the first picture that had normal vehicles moving on the highway. These vehicles, I managed to clean up that image and extract out what I basically needed. After cleaning, I tracked each and every vehicle on its movement from one point to another. Then I was able to come up with a background after extracting out only the important things that I needed in this picture. Then the model selection and optimization. The convolutional neural network is used here. It consists of multiple layers, namely the convection layer, pooling layer, and the fully connected layer. Hyperparameters used to tune in the CNN and learning rate, bunch size, and the number of options. Number of options in the number of times the entire dataset is passed through the model during training. Learning rate is the step size used to update weights during the background propagation. Then I will provide an accountability for my AI. Basically, I'll start with defining what's the accountability. It refers to the responsibility and transparency of the use of AI in decision-making processes and impact on individual society. In the context of our system, we took an AI accountability into consideration by training the model on high-quality data and tested it. We evaluated it, and we evaluated the model in rigorous and transparent manner. This model was tested on up-to-date traffic, and it managed to come up with something that manages to overcome to all the controversies that it might find. Then this is a sample of our graph results that we used to be able to come up with the comparisons. And these are my references I can give you on the system that I've been working on. Thank you.